Welcome again to the Nedscaper webinar about Azure Network Security, in which we are going to do some attacks, protections, detection, and response on the components in scope. The agenda for today, I'll do a short introduction about Nedscaper. We're going to talk about the Azure WAF, the Azure Firewall, Azure DDoS protection, and at the end, Microsoft Sentinel. Again, we'll do some attacks, see how we can protect against those attacks and the detections and how to respond. That's a continuous process which involves the people, process, technology part. Quick introduction about Nedscaper. Nedscaper provides 24/7 managed XDR service from our offices in Amsterdam and Cape Town, in which we deliver threat protection, continuous vulnerability, and threat intelligence. Threat intelligence will also be part of the topic later on in the Sentinel part. We also provide consultancy service on identity, security, compliance, and red teaming. With that, let's first start with Azure XDR. So I think we all know Microsoft Defender for Cloud. It's a product to detect and respond to attacks on Azure services like IaaS and PaaS, but it's on the operating system and on the PaaS resource level. But there are also attacks like internet attacks, like on the application and protocol level, like port scanning, cross-site scripting, SQL injections, etc. So Azure Network Security consists of three major components. The first one is the Azure Web Application Firewall, and that's basically the product to protect against web attacks, for example, the OWASP top 10 on the HTTPS protocol layer 7. The Azure Firewall, which basically protects in and outbound internet traffic, and it has some advanced security features which will be covered later on in the presentation. And the Azure DDoS protection, which protects Azure public IP addresses from distributed denial of service attacks. And at the end, we will ingest some log files into Sentinel and do some interesting things with that. Now, let's first start with the Azure Web Application Firewall. For this demo, I've set up a lab, which you can all do yourself. So what I included in the lab is the Azure Web Application Firewall on the Azure Application Gateway. I deployed a damn vulnerable web application server. I used a Kali Linux machine with some tools like Mask and Nikto, SQL Map Worksheet, and I have Microsoft Sentinel connector deployed, the Azure WAF data connector. So the attack itself. So what we will do.
Sorry, Dirk, your screen.
So, I didn't share the screen. A second.
Yeah, also your camera.
Yeah, that's on purpose, so people can focus on the screen, but then I should share the screen. So I think we missed a few items, right?
So your screen is shared since we see the main slide, but it hasn't moved since.
Oh, that's strange. Let's try to do it again. So this is the welcome screen you're seeing now. And do you see the agenda now?
Yes.
Okay. So quick recap then, also for the people that joined the call again. The agenda for today, I will skip the Nedscaper introduction, but we will going to talk about the Azure WAF, the Azure Firewall, and the Azure DDoS protection. And finally about Microsoft Sentinel. Let's skip this slide. What I talked about is that Microsoft Defender for Cloud does detections on the operating system and on the PaaS resource level, but not on the layer 7 web application and protocol level. Now, Azure Network Security consists of three components, the Azure WAF, the Azure Firewall, and the Azure DDoS protection. We'll go in depth into the products in the presentations of the separate components. So this was I was at, the Azure WAF. So now we're going to start slow again. So for the lab setup, I'm using the Azure WAF with the Azure Application Gateway, a damn vulnerable web application server. That's a VM you can download from the internet, a Kali Linux machine with some tools on it, and Microsoft Sentinel is configured with the Azure WAF data connector. The attack I'm about to do is first we'll start with a mask scan. Mask scan is a tool to scan the internet for specific ports, for example, port 80. Then I'm going to use NICTO, which is a web application vulnerability scanner, to see if there are vulnerabilities on the web server we discovered. I'm using Burp Suite. It's a web proxy pentest tool, and finally SQLmet, which is a tool to do some SQL injections. Now let me share my machine. Let's log on. So first start with a mask scan. So I'm using an IP range /24 and see what's happening in there. So there are some IP addresses which we discovered. For example, let's choose the first one, that's the .9. What I want to do next is the NICTO, which does scan if the web server has some vulnerabilities. So let's copy paste, paste, and go to the vulnerability scanner. Now this takes a little bit longer, so we can go to this screen, which already did the scan. Now, first of all, what's interesting to see is that the header detected is Microsoft Azure Application Gateway. So it already sees there is an Azure WAF in front of it. And for example, what we can see in here, there are databases on the server. So it might be interesting to do a SQL injection. Now, for that, we are going to this part. So let's open Firefox. Hope the logon works. Don't save. So we'll change the security level to low. And here you can see this is our then vulnerable web application server. Now let's go to the SQL injection. And if I do this, we'll see that something pops out. Now what I want to do, I want to use Burp Suite in intercept mode on. So now it's between the web browser and the web server. So if I do it again, we'll see we have the referrer and we have a session ID. So let's use this session ID. Let's copy that in our command line, which we will use for our SQL injection. And copy this command. So going back to the Linux machine, if we do clear screen, and we'll do the SQL injection with the session ID we just discovered. One second. And here's our SQL injection. Let's enter a few times. And here we can see that we found a database, we found some usernames, we found some password hashes, which can be decrypted to the password itself. So here we can see that with very easy steps from a scan to a vulnerability scan to an exploit, we have access to a web application server. Now, that was the automated attack. What we can do with the Azure WAF is basically you can protect against those types of attacks. We have two modes in the Azure WAF, and the first one is detection mode, the second is prevention mode. So let's use a more complex SQL injection manually. So let's go to this screen. Again, this is our SQL injection screen. And if I submit this SQL injection, we can see a lot more info, like indeed password hash, logon name, username, etc. So if we change the policy for the WAF, it's now in detection mode, prevention mode. Oh, 1 second. I need to quickly do something because we implemented security permissions. Uh, 2 seconds. Oh, I think, let's see how quick it is. No, I think I will come back to this demo after the Azure Firewall demo because I need to set some privileged permissions, which can take a few minutes. So first, let me hand it over to Rogier for the Azure Firewall part. And Rogier, when you're done, quickly hand it over to me. I will do the final part of the Azure WAF demo before we continue. Thank you.
Rogier, you're muted.
Okay. I should be unmuted now.
Yes.
Yeah, we can hear you.
Okay.
Thank you.
Yeah, no worries. Okay. I've also tried to share my screen. Well, welcome. Thank you for waiting, of course. I'm going to show you a couple of things about the Azure Firewall. The Azure Firewall isn't the most sexy resource within Azure, but it's still really powerful. So Derek just showed us where you can use the web application firewall to protect against threats from the outside. But as we might know, a lot of threats are also coming from the inside, and that is where the Azure Firewall can come into place. You can use it from the data that's coming from the internet into your internal network, but you can also use it to protect the internal network for the data that flows between your hub-spoke model within Azure, so within your own network, or going from your internal network out to the internet. The nice thing about the Azure Firewall is that it's got a centralized logging system where you can configure to send all the logs to a Azure Log Analytics workspace and use the KQL query language to check into all your logs that you receive. Based on those KQL queries, you can also create a customized dashboard. Microsoft has some very nice dashboards available that can show you stuff about the availability of your Azure Firewall and also the intrusion detection and other things. One of the things I'm going to show you is something about the threat intelligence module, which is built into the Azure Firewall, something about web categories and the intrusion detection prevention system, which has got the abbreviation IDPS. Quick side note on that, 2 days ago, the Azure Firewall Basic has been released in preview. It can do a lot of things that the normal Azure Firewall does, but it's more focused on the smaller businesses. I think up to 1,000 users. It misses a couple of very advanced features. So it does some threat intelligence filtering to malicious domains and IP addresses, but it can only alert it, whereas the standard firewall and the premium firewall can actually block the traffic. And also the TLS termination for inbound and outbound traffic is only available within the premium as URL filtering on filtering path. So look it up and let's continue. Little explanation about the lab setup that we've created. So we've created a virtual network that contains a compromised virtual machine where a bad actor has access to. All the data from this virtual machine is being redirected through our routing table to the Azure Firewall, whereas the Azure Firewall is going to check if the data is allowed and log all the allowed and denied data to a log analytics workspace. If any incident is created, that's also being synchronized to the Defender for Cloud and also to Microsoft Sentinel, which has the connector for the Defender for Cloud, where my colleague in a later session will come back to. I'm going to switch to my virtual machine, so I'm just going to switch my screens. Okay. Here we are. So we are logged into a working machine of a compromised user, admin Jack, and the bad actor is trying to open some vulnerable URLs to download his own software. So to simulate that, we've created a script called RedScan, where we can do a scan on the threat intel module. So what this basically does is we are connecting to the threat intelligence page of Microsoft. We download the publicly known threat indicators and trying to query those and see if they're being picked up by the Azure Firewall. So we're going to run the script. Red is running, and as you can see here, we are querying a couple of websites that are being pulled from the Microsoft Threat Intelligence page right now. So if it takes a little bit longer, that means that it's probably being blocked by the Azure Firewall and then gives a timeout. So let's sit and wait for a second. We will also publish this script after this webinar, so you can download it from our GitHub and try to self-inspect your own firewall. It does work for the Azure Firewall, and if you have another firewall, that use threat intelligence, you can use the same script to test your own devices. So now the script is run, so potentially the bad actor is trying to connect to all these Russian websites. Unfortunately, they're all Russian. So let's see what happens within the log analytics workspace. So here we are in the log analytics workspace in Azure. And what we're going to do here is look into the Azure Diagnostics table, where all the Azure Firewall logs are being stored. And we're going to search for XHPH, which is actually the domain that was being called. And we are explicitly filtering on this because it gives a bit less results. So you've got the latest results. And if we open up one of the results, we've also run this before. That's why the times are a bit different now. You can see here that the virtual machine that we were logged in, the 10.0.10.10, tried to access this web page, the XSPH Russia through port 80, and tried to open a file called dears.txt, and that action was being denied by the Azure Firewall using the threat intel destination. So what actually happened in the background is the Azure Firewall's got an integration with the threat intelligence platform of Microsoft, whereas if the new threat indicators are available, Microsoft will publish this to all their firewall instances, so you don't have to worry about missing links in there. They always try to update it pretty quickly and try to keep you safe. I'll go back to the presentation. So the other situation that we have, there was actually the thing that we just did. So we executed the script downloaded files, which were the public identifiers. They ran through the firewall and the data flew out. Okay. The other thing is the Azure Firewall IDPS, which is also a premium feature within the Azure Firewall, which stands for Intrusion Detection Prevention System, which is based on signatures. So if there's a known malware, they will get a signature. Microsoft is provisioning between 30 and 50 signatures per day and updating firewalls in the background, and will also push those to your Azure Firewall instances. So if a malware execution takes place and Microsoft recognizes that IDPS header or a bad agent or anything of that kind, it will at least create an alert, and if you configure it correctly, it will also block it. That data will also be stored in a log analytics workspace again, but also being sent to the Defender for Cloud that a machine tried to use a invalid agent. So I'm going to show you two examples. Again, back to our, oh, here we go. It's a bit too quick. Back to a vulnerable admin check. And what we can do here is call our same red scan again and say we want to test the IDPS. And if we do that, you will see the script will try to call a web page using different agents, user agents, whereas the Mozilla 5, Mozilla 3, and the Hacksterman are known vulnerable agents, and those will be detected. I've also added Internet Explorer on purpose, because we do know that that is a valid agent and wouldn't be blocked by the IDPS module. The script also outputs the time date stamp, so it makes it a bit easier to search in the logs. So I'll go to the next page where we've got the IDPS sample. And if we run the query here, again, you can use the same language, run it against the same table and the same column within the table. And let's filter for the latest items. Here we go. And if we open up this one, you will see that, again, this machine, the 10.0.10.10, tried to connect to this IP address, whereas it had a signature that was known as vulnerable. And this one was a suspicious agent called Hacksterman. In this case, we let the data through. Otherwise, we really let it wait for about 5 up to 10 minutes per agent before it got timed out, and that would be very bad for the demo. A other situation that can happen is a user that receives a document with a link or downloading a file because they like to play games. So we've got a couple of samples here. We've got the Roblox cheat loader, we've got an invoice, and we've got a Tesla configurator. So a user received a document with invoice and an email, and she was asked to sign the document. So the unaware user opens up the file, And of course, you turn off all the macros in our office because it's really annoying when you every time have to click in the yellow bar and disable all the features. As you see, hey, this is a strange invalid document, probably the wrong document. So she closed it up again. But what she doesn't know is that in the background, a malware was being loaded. And in this case, a slot machine William 32-bit was being published to that machine. So what this actually does is that it tries to connect to a website and using a user agent that is known vulnerable. What also can happen is my daughter likes to play games like Roblox. She would download a piece of software called Roblox. Well, nothing happens here. So with the Tesla configurator. But if you see here, again, the slot machine Williams is being loaded. So let's see what happens in our log analytics workspace again. And hopefully this is going to work. Again, it can take a bit before it's all being provisioned. And here again, we can see a result from a different machine than previous. This is 10.0.10.10, whereas that machine tried to connect it to this IP address with a different signature. So if you might remember before, we had the Haxerman, which was the user agent we're trying to call. And in this case, a piece of malware is being loaded and trying to extract data from the machine. And this will give several alerts as we have opened the document and we have also opened the other executable files. So again, if you have an unaware user that's opening an Office document or opening an executable that they didn't know, and there is a header in there that's trying to connect to an endpoint with a known malware in there, that will be detected by the Azure Firewall and of course being blocked and help you to protect your environment. So let's go back to the demo, to the PowerPoint presentation. Again, so the bad actor tried to execute the malware, ran into the Azure Firewall, the data was being logged in the workspace, and the vendor will picked it up and will also be visible in Microsoft Sentinel, as my colleague will show later. So what more risks can the Azure Firewall help us with? Well, the other thing is that you can configure web categories. As admins, we know it's a lot of work to configure and include and exclude all the websites that are being allowed to be browsed by users or need to be declined. So what if you have an insider user, which can be an insider risk user, that is browsing websites that are not allowed within the organization? They can be either websites that host malware, that it can be that you want to prevent websites being browsed containing alcohol or drugs or any other stuff. But of course, it could also be a GitHub repository, whereas in general, you don't want to block a GitHub page, but with the smart filtering in here, you can exclude specific GitHub sites. So you can exclude github.com/AAD internals or NetSpy, which hosts some scripts and software that you can use for exfiltration of data. So again, we go back to our machine and here we go again. So what it actually looks like is if we just open up a browser and we would go to google.com, that obviously is going to work if the internet connection is working. Well, it is. So let's go to a GitHub page, which is all being fine and all the data is being logged within our log analytics workspace again, because it flows through the Azure Firewall. But what if the same user is trying to find some more information about alcohol? If you're working for an anti-alcohol clinic, you don't want your employees to look up some booze, right? Here we go, www.heineken.com. Okay. Let's press enter. And now we suddenly see that this website is being blocked. And why is it being blocked? Because the Azure policy that we configured, firewall policy, said that any explicit data is being blocked that contains alcohol or tobacco. You can do this for a lot of different categories and really help you. So you don't need to block the website of Quarantine Tres or Bacardi and Heineken and all the different other websites that you can make up. But just look into the category that falls in, and then make sure configuration a lot easier. So how does it look at the other side? Well, if you go to the Azure Firewall configuration policies in this case, you can go down to the web categories, which can help you to configure the categories. So as we just did, if we look for Heineken, Heineken.com, and we look it up, it will tell you in what category it is. Well, in this case, it's the alcohol and tobacco category. So if we go to Nedscaper, for example, that will give you a different category. And I'm sure you don't want to block Nedscaper, so don't block the information security in your firewall, please. Otherwise, you can't browse our websites. But it's really a helping hand to help you to determine what kind of categories you need. So if you really want to configure that, you can go to your policies and go to your allow or block web pages. And if you go down here to the web categories as a destination type, you can open the destination, and there's an extremely long list of all the different kinds of topics that you want to exclude or include from being browsed or being denied by your Azure Firewall. So this really helps us as admins to configure it easily and smart. Back to the PowerPoint. So as you've just seen, we've got an inside risky user who was browsing for websites that weren't allowed within the organization. That was being detected by the Azure Firewall. The data ran through the Azure Firewall policy, and the data either get allowed or denied to go to the internet. So this is just a small summary of the thing you just saw. You can look up the category type, and you can select the properties that you want to block. That was it for the Azure Firewall. And I will now hand it back to Derek, I think.
Yes, yeah, let's quickly do the demo again with the correct permissions. So we were at this screen. We can do a more advanced SQL injection that we get more data out of it. Still, the web application firewall is in prevention mode. Let's switch to detection mode. Prevention mode is the mode you should run if you deploy the WAF and see what's going through and what is blocked, basically via the logs, etc. And if everything's filtered out, you can set it to detection mode. And again, if we go to the SQL injection again, we'll see it's blocked by WAF itself. So this is the example of the WAF prevention mode. And with that, I want to hand it over to Stefan with the Azure DDoS protection demo and presentation.
All right. Thank you all for joining. So I'll talk a little bit about the Azure DDoS protection plan, and I hope to answer like these 4 questions for you. Like, what is it? What can it protect? How does it work? And why do you need it? Well, the last question is more one that you really should answer for yourself, but at least the demo that I'm going to provide will give you an idea of what can happen if you don't have it. So the Azure DDoS Protection Plan Standard, it is a turnkey solution that basically protects your assets against layer 3 and layer 4 volumetric and protocol attacks. If you need protection against layer 7 attacks, which would be resource attacks, then you'll still need a web application firewall, which can be the Azure WAF, or it can be one from a third-party vendor. It doesn't matter. The resources that it can protect, let me mark that real quick. Here's my laser pointer. So the resources that it can protect is any public IP address located in a RRM-based Azure Virtual Network. So how it works is you link the Azure DDoS protection to a virtual network, and any asset in that network that has been assigned a public IP address will be automatically protected by the DDoS protection plan standard. So it doesn't matter what is behind the public IP address. It can be any kind of resource that can be configured with a public IP address. So how does it work? The DDoS protection plan standard, it continuously monitors your traffic and it will create a policy. It will create a baseline based on the pattern of the traffic that is normal behavior. When that policy needs updating because, for example, your volume increases, then the thresholds will be automatically updated in the future as well. So if you scale out, the policy will adapt. If you scale back in, the policy will lower the threshold as well. Now, during the mitigation, so when the policy detects like there is abnormal behavior, like there is a big, massive spike of traffic occurring into one of the public IP addresses, the mitigation will kick in shortly. The mitigation comes in 3 flavors. It will check for malformed packets, like if it actually, if the packets are behaving like according to the protocol it should or not. It will attempt to see if the packets are spoofed or not. It can do that, for example, by dropping a packet to see if the client will send a retry or not. And if both of those methods fail, it will apply a rate limit. So why do you need it? Let me bring up one other article real quick. This Microsoft Learn article, you might have seen this table before, and this one might confuse some people. Like it says automatic attack mitigation, yes, for both the infrastructure protection, which previously was called DDoS protection basic, and the DDoS protection standard. So it says both that there is automatic mitigation happening. The thing is, though, that for the infrastructure plan, the thresholds are significantly higher than the resources that you are going to be hosting in the Azure cloud. Those infrastructure thresholds are not made to protect you, but they're meant to protect the Azure fabric itself. So you can't really rely on the DDoS protection plan that is already always enabled for every customer because it's not scoped for your resources. Those thresholds, they will simply not be, they are just too high to protect you. So that's basically the reason why you would need the DDoS protection plan standard, because every individual public IP address that you have assigned in that virtual network, it will get that automatic policy tuning based on the behavior and the volume of traffic that it is processing. So if you have one very busy public IP, that one will have a different threshold for the DDoS protection plan than a lower volume public IP. So next, I have prepared a small video because I'm not able to demonstrate this live. The demonstration would take too long. So I have prepared a video recording that I've cut into little pieces here and there to consolidate 15 minutes in about 3 minutes time. This is the lab setup that I had for the video. So we had a virtual network that was protected with the DDoS protection plan, and we had an unprotected virtual network which hosted a virtual machine. It was the same damn vulnerable web machine that Dark mentioned earlier. They're both assigned a public IP address. I'm using that for demo purposes to actually show what the impact is when you are attacking a public IP. And one last thing I want to highlight is the signal of the events. So you can have your Azure DDoS protection. By default, it will signal Microsoft Defender for Cloud, and all the alerts would go over there. But additionally, you can also add the diagnostic logging for a public IP address to a log analytic workspace, for example. And that log analytic workspace, you can use that along with Microsoft Sentinel and the data connector for Azure DDoS protection to visualize like what is happening during a DDoS attack. You will be able to see more things like the kind of volume that went through the DDoS attack, and there are no analytic rules that are provided with this data connector. It is just there to visualize data. And the other way to actually get the alerts into Sentinel would be to just use the bidirectional Defender for Cloud data connector. So in the screenshot that I have next after the demo, I'm actually going to show that the events in Microsoft Sentinel can be both provisioned either from a log analytic workspace with a custom query, or you just rely on Defender for Cloud. All right, so I'm gonna drag my video over here. The testing solution that we're using for DDoS assimilation, it is a Breaking Point Cloud. I have a public IP address over here that I'm going to be attacking, and that same public IP address is the one that I'm actually querying all the time. So I'm using PS ping. It's just like ping, but then on TCP level to just see if this particular IP address on that particular port is available and what the response time is. And the PowerShell script on the right bottom that will just basically do the same thing as if you have a web browser open and you press F5 the entire time. So I'm going to start this. First off, I'm just going through the DDoS protection plan. Here is the protected asset that I have. It's the application gateway. I will obtain the public IP address of that. So you can actually verify this is the same IP address. And initially, the Microsoft Sentinel portal was empty. So during the recording, I actually attempted to do DDoS attacks earlier in the day. So that's why you see some spikes in that graph over there. First off, this was one thing I wanted to highlight. Also in the Azure Diagnostic Logging table, you can get the events of the public IP address, and when DDoS mitigation happens, you get both an alert when it starts, but also when it stops. So this was one of the earlier events when the DDoS actually stopped. And I simply wanted to show how it looks like when you get one of those events. So now I'm going to start the connectivity tests. You can see that if I just press F5 on that particular web server, it will respond immediately. All of these connectivity tests, they have relatively very low response times. And then I'm going to start the DDoS attacks. And once this ramps up, you will immediately be able to tell that there is a difference in the behavior of the response times. So in the lower left, you can already see there is a timeout. Sometimes there are response times of 1 or 3 seconds. It is no longer a responsive web application. On the lower right, there was actually it went by very quickly, but as you can see, there's no scrolling text anymore. When that happens, it is just waiting for the timeout of the post request or get request. So basically, right now you have a non-functional web server anymore. So in this particular case, I was only hosting one website. But imagine you're using this application gateway and you're hosting 10, 20, 30, 40 websites. All of those websites would be down. So just think about that, whether the default DDoS protection plan is sufficient for your needs or not. So as you can see on the bottom right, the application gateway has actually produced a timeout error, and the browser will result in the same. So right now we're dealing with a completely dead website, basically. I'm just going to skip forward a little bit. So yeah, I'm going to try that one more time. I was impatient. One of my lesser qualities. So there you can see that the browser reports exactly the same thing as the PowerShell session in the lower right. So I'm going to skip forward a little bit. This is the other public IP address that I was talking about in the diagram that I made. This is the public IP address of the web server itself. The reason why I had that one on a public IP is so that I'm able to connect to it while I'm performing this DDoS attack. Otherwise, I would need to first connect to the local network and stuff like that. So as you can see, during the DDoS attack, the web application firewall, the application gateway, that is actually the resource that is unavailable. However, the resource behind it, it is very responsive still. So I'm going to open the browser one more time, just to show that the application gateway is still causing the timeout. And then I will drag in the other screen where I will access the public IP address of the web server itself. So right about now, the DDoS protection mitigation has started. That is the event that was produced to the diagnostic table. And shortly after this event, you can already see the behavior has pretty much restored connectivity. The response times you don't see are very low. You don't see any timeouts anymore. So that is basically the big difference between whether you have your DDoS protection plan standard or not. If you don't, you basically will have an unavailable website for the entire duration of the attack. It doesn't even have to be a website. It can be any kind of service that you publicly have available on the Azure cloud. So after a while, the log analytic, the analytic rule that I created to create a Sentinel alert based on the event mitigation started. That is the keywords that I use in order to create this event. This is one way to deal with getting an alert in Sentinel. The other way would be to simply use the Defender for Cloud connector. And this is the last thing of the video. It's the metric that actually shows that this particular IP address is under attack or not. I'll have another slide about that in a moment. So this is basically the two ways how you can get alerts. First, you have Defender for Cloud. I actually did not. I wanted to. No, sorry, messing it up. So you have Defender for Cloud. And you have Microsoft Sentinel. Within Defender for Cloud, you will get events that will state whether a public IP address is under attack. It will give you the IP address that is under attack in the description. And within Microsoft Sentinel, you can either use the Microsoft Defender for Cloud connector, and then all of these events that show up in Defender for Cloud will automatically show up in Sentinel. Or you can use your own analytical rule, and then the product name will simply state this is an alert that has been created by Microsoft Sentinel. So my last slide is a quick time lapse described in the metrics. So the metrics are basically just the information like how much packets are going through at what time and all of that kind of stuff. This is the moment when I started the DDoS attack. This was actually a different day, but it doesn't matter. And after several minutes, as you saw also in the video, it doesn't kick in immediately. There is usually a a delay of about somewhere between 5 and 10 minutes. That's my personal experience. Before the DDoS protection plan detects that there is a DDoS attack happening. Once that threshold has been reached and the policy states, okay, we're going to start the mitigation, then this time frame is relatively short. The dark blue line, that means it's scrubbing the traffic. So during this period, the traffic is scrubbed. And here you can actually see I stopped my DDoS attack, but the DDoS mitigation was still effective for several more minutes, like 15 minutes or more or less, before it dropped back to its normal behavior. I hope that with this information, you've gotten a little bit additional insight about how the DDoS protection plan can actually help you, and what happens if you don't have it. And with that, I'm going to give the microphone over to my colleague Matthew.
Thanks, Stefan. Cool. Hi, everyone. I'll be going over just a quick thing of Microsoft Sentinel, with the main focus being on the threat intelligence and how the threat intelligence can be used to trigger alerts, such as when when an IP is found in your threat intelligence database, and then somebody also signs in to one of your accounts in your Azure AD environment. That, of course, will trigger alert. So just to give you a quick summary of the threat intelligence portion here. So for this particular one, we're basing it off of Azure WAF. So we have an Azure WAF deployed, such as the one that Derek went over. An attacker, of course, targets that particular IP, triggering logs. Those logs are sent to the Sentinel solution. In those logs is the actor's IP address. That IP address is then sent on to threat intelligence application. So in our case, it's a custom one we made. And what that application does, it does a whole lot of basically statements in that to check, basically to give the IP a rating. So in this case, things like, does that IP come from, for example, Russia versus does it come from Spain? Does that IP, how active is that IP in my own environment? And those kinds of conditions then grant that particular IP a classification for how long it should be in our threat intelligence database. And that can be anything from it being in the database for 2 days to it being in the database for 14 days. That IP is then placed into the threat intelligence database in Sentinel. And then, of course, you can take advantage of that with a lot of even Microsoft's own default threat intelligence rules. So in our example here, and I'm just going to go over what we'll do the live demo, we'll be looking at a whole lot of alerts that have triggered. And in this case, we're focusing on the 194 IP. In this case, this IP is actually one that was used by Derek. A few things to note here is us quite easily being able to search for an IP address in Sentinel. One of the big benefits that Sentinel has, and one of the foundations that Sentinel is built around, is entities. And entities can be anything from an IP address to an account, to an email address or an account name, to a device name. And those kinds of entities are important because it allows you to correlate different alerts in your Sentinel environment with each other. And those alerts can be from Microsoft themselves. Those alerts can be your own custom Sentinel rules you created, or they could be from third-party solutions. So in this case, we can actually see that this particular IP has been found in quite a few alerts, some of them actually even rated high. This AWAF are actually just custom Nedscaper alerts that we've created for picking up on different kinds of attacks when targeting a WAF. So in this case, we can see things like SQL map, recon through past traversal attacks, etc. And then finally, the other thing to note here is then the TI map IP entity triggered. This one's very important because we've now gone from tagging and noting an IP in the WAF to actually finding that IP being used by one of our users in our environment. And through this method, you're able then to, of course, aggregate the alert, investigate, and hopefully come to a remediation. So move on to the next one. So final thing just to note about Sentinel is it's based, all the querying and that is based on KQL, that's the Kusto query language. You do not need to actually know it to do an investigation. And one of the big benefits that it does grant is the investigation graph. So in this case, I'll just go over a quick example of the investigation graph. It'll look a lot like this as an example. I'm just showing it here just in case we have any problems. We hopefully shouldn't. And again, the things to note about the investigation graph is it's 100% based on entities again. So you can see here, we actually have our alert name here. So TI map IP entity, and we have two entities. We have the IP address and we have the username. And with the investigation graph, it allows you to expand out and see how many other potential alerts in our environment have triggered based on this IP. So in this case, and again, it's a lab environment, we can see that there are quite a lot of other alerts that have triggered in this environment. And every single one of these other ones are all related to either a WAF or a sign-in based on a threat intelligence IP mapping. I will now hop over to our Sentinel environment. So this is a refresher. Okay, so for those that don't know, this is just the Sentinel overview page. So basically the landing page for Sentinel. Just a few things to note here as we're looking at the last 24 hours. We have ingested 194,000, around 194,000 events. And from those events, there are 47 alerts. And then, of course, another thing to note here is you can see there's quite a big spike around here. So that's about between 2 and 3 around now as well. That's, of course, related to the activities my colleagues have been performing. The other thing then, of course, is your recent instance. So you can quite quickly view down what has recently triggered. For this particular webinar, we're going to be focusing on the threat intelligence. So I'm going to hop over to the threat intelligence database. It's its own separate tab here in Sentinel. So if we click on here, we should load this. So again, your threat intelligence can be anything from IP addresses to domains to hashes, etc. In this case, we are sitting with our lab environment with over 122,000 threat intelligence data types. Something to note is that there's a 90-day retention period in Sentinel. So, and with the threat intelligence, you can also set expiration dates. So, and this is one of the things we use with the WAF one is we might only want an IP to be part of our threat intelligence for 3 days. That IP will still sit in the environment for 90 days, but it will then change from being active to, I think active to expired. So just something to note on that. For this particular one, we are going to look at our WAF honeypot. So what this is basically telling us, these are IPs we picked up from our honeypots that are based on web application related attacks. So basically what you're going to be looking at with your WAF. So if just doing a quick search function here, we can just drop this one over here and we get a few values. So off the top here, something to note here is this column over here, which says alerts. This is actually a very nice column because it can tell you how many alerts a particular IP has triggered in your environment. So just off the bat here, we can see this 194 IP has triggered 20. And if we go down to the 104, we can see it's 1, etc., etc. So some of the nice benefits that can bring if you bring your own threat intelligence or you have your own custom one set up like what we have, and this is funneled through to MDR clients, is you can potentially pick up on attacks that are occurring quite recent, potentially even before other products, depending on where the resources sit. So for this example, I'm going to take, let's say this 159 address. So if we take this 159, it's actually triggered an alert in our environment. If we scroll down here, we can see it triggered on the 25th of September. We can see that our threat intelligence database now has tagged it from the 25th of September to the 27th of October. So that's how long it will be sitting in our environment and be considered something potentially either malicious or interesting, and therefore should trigger an alert. If you go over to something useful like Abuse IPDB, you can run it over here. You can see the IP is from India, but there's actually been no reports on this particular IP. And we can follow the same process here with this one. So again, nothing much here on this one. So if you potentially have an analyst doing something, doing the checks, they just checking based on abuse IPDB and that, though not recommended, but they might come to the conclusion, say it's not malicious at all. Let's take another IP here as an example. So this one with 4, just to show you how a more severe one would potentially look. And here's one from Russia, and you can actually see it's got quite a high confidence level. So being able to ingest your own threat intelligence and also hosting your own ones can also be quite beneficial to your environment, because it provides that additional protection, not just relying on one particular threat intelligence product. You also have, well, in our case, our own custom ones, which we control, where we deploy it, how it functions, and what the logic is behind that particular threat intelligence. So finally, we're going to go back to our 194 IP address, because for us, if we scroll down and look at the columns, this is actually our most severe one. So if we are going to go and see, okay, how many, there's 20 alerts that have triggered, let's go investigate and see what particular alerts have triggered and how you can potentially come to a conclusion based on these alerts. So for that one, we're going to hop over to the incidents tab, which is this one over here. So we're now on the incidents tabs. What this is showing is in the last 24 hours, there have been 72 incidents in our environment. 5 of these are high and 67 are medium. This functionality works quite nice, where we can quickly hop from one to, for example, let's go look at the last 7 days. So we click on the last 7 days, we're now sitting on 156 open incidents. The other nice thing it brings is the search bar here. So based on the entities, I can actually just search for all the incidents that have this particular IP. I just got a tab here. And if I press enter now, it should hopefully load it down. Yeah, there we go. So we should now be looking at every incident in the environment that has this IP in it. So if we go up over here and we say, let's have a look at this SQL injection exploit. If we click on this, this is a custom alert from Nedscaper. It's triggered, and we can see the entity here. So the 194.49.52.100. A few other things that we can see is that it's actually triggered quite a few events, and the creation time, or when this particular alert triggered. So this one actually triggered on the 3rd, so a few days ago at 6 p.m. If we decide now we want to drill in and do a larger investigation to something, we can go do that via the viewing the full details page. So in this case, I'm actually going to look at the TI map IP entity one. This particular alert that triggered is actually one of Microsoft's ones that you can deploy as part of using Sentinel. It's basically a template that they share in GitHub and here in the Sentinel environment. And if you are using that particular data connector, such as sign-in logs, which are your Azure AD logs, you can then take advantage of those pre-built KQL queries. So in this case, what this query does is it checks every sign-in log. So anytime somebody authenticates to the Azure AD environment, it will then check the IP and see, is that IP in the threat intelligence database? And if it is, it'll trigger an alert. The other thing to note about this alert is we actually have 2 entities in this case. And we have 2 entities because we have that IP again, and we have the account that attempted to, or that successfully signed in. And again, this is the big benefit this one brings, because we're now combining sign-in logs with the logs we're getting from sign-ins and the information there with ones we got from the IP on the WAF. So if we click on view full details, this will bring us a little bit more information on this particular alert. The nice thing that was recently released was the similar incidents tab. This one's very nice and helpful because, again, it takes advantage of the entity mapping. And what this does is it looks at the last 14 days and it'll let you know, are there any other incidents in your environment that have triggered based on either the IP, the account, or both. And in this case, we can see, again, being a lab environment, quite noisy, but we can see quite a few alerts have triggered. So if I hover over one of these with the similar incident entities, we can see it's the IP that's similar in this one. And if I hover over this one over here, which has the +1 here, we actually have the count and the IP. Another nice thing this does is, especially if you, as an analyst, to save you a bit of time, is it allows you to see, oh, okay, this particular incident ID 294 that triggered on the 6th, which was early on today, has been closed as a false positive, and we can see that who closed it. So John, one of our colleagues, closed this particular incident. So now if I'm investigating, I might also, as part of the investigation, get hold of my colleague John just to find out why did he close this one as a false positive if for whatever reason the description he added there wasn't good enough. And then finally, if we want to do a bit of an investigation in it, we can use the investigation tab. This is especially useful if you are not very familiar with KQL. I do recommend, if you are going to be doing Sentinel and you want to be investigating stuff, is to be familiar with KQL. Using the KQL language is much more versatile compared to this, but this is also quite effective at what it does. So what this is doing is it's, again, showing us the alert. It's showing us the two entities. And we, for example, want to see, based on this IP, how many other potential alerts have triggered. So if I click on here, it now opens up a whole lot of other ones. And the other nice thing it can do is based here on the timeline. So this one's a bit messy now because so many have triggered, but hovering over, you can see which one's triggered first based on the time generated, and allowing you to know where to start your investigation and where the initial compromise might have potentially happened. Finally, though not in this lab environment, the other nice things this does is it integrates quite nicely with things like Defender for Endpoint. So for example, if Derek's had a device that was onboarded to Defender for Endpoint, you would be able to link up that device as well. And linking up that device now adds an additional entity to your investigation and the potential another point where you'd want to go find out, is that device running anything malicious? Is anything funny on that device, etc. And yeah, that's it from my side. Just doing a quick summary of an investigation, showing you some threat intelligence with some of our own custom use of the threat intelligence database from Sentinel, and then of course just showing you how to use the investigation graph. And hopping back to the slides, that's it from my side.
Thank you. A little bit over time. I think it was very interesting. So really want to thank the presenters and the participants. A few questions in the chat there, what they are answered already. If there are questions, let us know. And like I said, within a few days, we will share the recording on YouTube. Thanks again, and wish you all a very nice day.